Hey everyone, welcome to TitanClass. On this episode of TitanClass, we're going to do a whole bunch of solving quadratics. Part 1, solve by factoring when a is 1, with a little GCF thrown in. Part 2, solve by factoring when a is greater than 1, with a little more GCF thrown in. Part 3, solving by square roots. And then Part 4, solving by completing the square. Let's get started. Woo. Part 1, solve by factoring when a is 1, with a little GCF thrown in. So, question 1, p squared minus 9p plus 18 equals 0. Okay, a is 1 here. Pretty simple, pretty standard. We're going to use the area model. P squared, 18. Looking for factors of 18 that I can add or subtract to negative 9. I'm going to need a 3 and a 6 here. And they both have to be minus. So negative 3p, negative 6p. Greatest common factor here is p. Greatest common factor is negative 6. Remember, when this box or this box leave with a negative, I've got to take a negative out. And I've got a p and a negative 3. So I've got p minus 6 and p minus 3. But remember, these are just my factors. My solutions are where I'm going to use the zero product property, which is just fancy terminology for set both parentheses equal to 0 and solve. So p minus 6 is going to equal 0, and p minus 3 is going to equal to 0. If I add 6 to both sides, I'll get p equals 6. And if I add 3 to both sides, I'm going to get p equals 3. So my answer here is going to be p equals 6 and p equals 3. But on the side here, I'll just put 6 and 3. All right. So these problems, again, when we're solving, we're looking for the factors first, right? We're solving by factoring. It's just our methodology that we're really familiar with, and that's going to help us solve these problems. Number 2, b squared plus b minus 30 equals 0. All right, again, area model. B squared and negative 30. Looking for factors of negative 30, but be careful, you know, our term here is 1. So I'm looking for factors of negative 30 that can add or subtract to positive 1, and I'm looking for a 5 and a 6. But in this one, I need a negative 5 and a positive 6, right? Because I need to multiply to negative 30, but I need to add to positive 1. So I'm going to have a negative 5b and a positive 6b. Take the greatest common factors out of each. Negative 5 here. So we've got b plus 6, and we've got a b minus 5. This will be b plus 6 equals 0, and b minus 5 equals 0. Subtract 6 on both sides, and we have a b equals negative 6. Add 5 to both sides, and we'll have a b equals 5. So our answers are negative 6 and positive 5 for number 2. Right. Off to a good start, I think, right? You should be really familiar with these problems. We've been factoring for literally weeks. And factoring is good practice with quadratics because we're going to get into some pretty heavy-duty stuff as we get further in Algebra 2. X squared minus 5x minus 6 equals 0. I hate this combination with a 5 and a 6. It's the worst because it could be a 6 and a 1. If I had it switched, it could be a 2 and a 3. Oof. Let's see what this is going to end up being. Hate this one. Yeah. Well, if you knew I hated it, why would you keep putting it on the paper, bro? Huh? Are you laughing at me? You are laughing at me, aren't you? Little punk? Huh? Just laying there? Laughing at me the whole time? Okay. So it's definitely not a 2 and a 3 here because I can't manipulate 2 and 3 to get a -5 and multiply to a -6. So it's going to be the 6 and the 1. Positive. Ooh. It's actually a -6 and a +1. Yeah, I know. I know it was close. I almost messed up. Stupid dog. Okay, so we have the -6 and the +1 because I have to add to -5, right? So we have an x and a 1 and an x and a -6. So we're going to have x plus 1 and x minus 6. Setting them equal to 0 gives me x plus 1 equals 0, and then x minus 6 equals 0. Minus 1 will give me x equals -1, and plus 6 will give me x equals 6. So my values here are going to be x equals -1 and 6. Titan, 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 Titan. I don't understand, buddy. Okay. Number 4. X squared plus 7x plus 6 equals 0. And again, area model is going to be the way we go with the majority of the problems we're going to do today, right? So especially when a is 1, when a is greater than 1, we're going to work through these processes. And it's going to take a little longer for this section. So, feel free to fast forward me if you need to get to the square root section, which is going to be a little different, a little fresh, a little new, but it'll also be a little bit quicker, right? So 6, looking for factors of 6 that I can multiply or add or subtract to get to 7. So it's going to be a 6 and a 1. So why do all these have 6s in them? He gets up now. I'm sorry. Come back. Come here. He left. He was just chilling right underneath here. He left. I'm sorry, buddy. I love you. Okay. He's probably going into his bed. X plus 1 and x plus 6 are my factors. And x plus 1 equals 0. X plus 6 equals 0. Minus 1 on both sides gives me x equals -1. And then here I'm going to have x equals -6. Right? Okay, so number 4. I was going to say, if this is exactly the same problem, -6. Can we have a problem that doesn't have an answer of 6? We have yet to have one. Whether it's +6 or -6. That's crazy. All right. This one won't have one. This is 5. Okay. X squared minus 13x plus 42 equals 0. Area model all the way. X squared and 42. Looking for factors of 42 that add or subtract to -13. 6 and 7. I promise you, I did not do this on purpose. And I really thought it wasn't going to be a 6 and a 7. Wow. I mean, -6x, -7x. This is crazy. -7x, -6. This is so stupid. X minus 7 equals 0. That's a 7. And x minus 6 equals 0. Sorry, I skipped the factors. So this is x minus 7. And x minus 6 are factors. Solutions are when I set them equal to 0, right? So x, we'll add 7 to both sides. And then x equals 7. And then we'll add 6 to both sides. I don't know what that was. X equals 6. This is crazy. 7 and +6. +6, +6. Now I really do think the dog was messing with me. He was near the laptop earlier, so when I printed this out, he was near it. He's a smart dog. It's feasible, okay? This one won't have a 6 in it, I promise you, except for the number. Can't make this up. Okay. K squared minus 5k equals 0. Okay, so, okay, right? That's not funny. GCF, right? This is not when A is 1. Well, it is A is 1, but this is more GCF than area model. We don't area model two-term quadratics. So in here, I'm just telling myself, well, I really want to find the greatest common factor that comes out. Well, k is the greatest common factor. So we pull k out. Then we're left with k, which is the division of k from k squared, minus 5. Okay? Now, we're going to set both of these parentheses equal to 0. That's why I like to put parentheses with the first thing I take out, because it's a really easy fix where I just set it equal to 0, and that's actually one of the solutions, k equals 0, right? So it kind of does it for me. So then I'll have k minus 5 equals 0, add 5 to both sides, and then I'm going to get k equals 5. So my two answers are 0 and 5. Not 6, right? But it's the question 6, so we really haven't gotten one yet without some kind of a 6 in the answer. But with it, when it's here, that's why we set it parentheses around the 1 letter, so I can just set it equal to 0. And it, like I said, it fixes it for me. Excuse me, by the way, just burped. Hopefully you didn't hear that because that's gross. Number 7. Finally, a problem that does not have a 6 anywhere near it. B squared minus 2b equals 0. Okay, yet another problem that is greatest common factor. So again, I'm just trying to find what both terms have in common, and that comes out alone in parentheses, b. And then what's left over is going to be b minus 2. Both are going to set equal to 0. It just so happens that this one kind of fixes itself nicely for me, where b equals 0. And then I'll have b minus 2 equals 0. And we'll add 2 to both sides. And then we'll have b equals 2. So my two solutions are 0 and 2 for number 7. Now, the way you write your answers is really up to your teacher. They may say put it in ordered pair form. They might say and. They might say put the letter in front of it. So for this one, it would have been b equals 0 and b equals 2. But again, it all depends on the teacher, and it all depends on how the answer is supposed to be represented. They may want you to put your answer in ordered pair form. So for example, remember that when we solve a quadratic, we're looking for the x-intercepts. So I might put 0, 0 and 2, 0. Again, all depends on what the instructions are and what the teacher requests. Number 8, p squared plus 10p plus 16 equals 0. Okay, so back to our a equals 1, we'll area model it all the way, where we have a p squared and a 16, and I'm looking for factors of 16 that I could add to 10, 8 and 2. Right, because 8 times 2 is 16, so we'll both have positives here. And then I get an 8p and a 2p, where p and 2 and p and 8 come out. So then I have p plus 2 equals 0, or p plus 2 is my factor, with p plus 8 as a factor. And then p plus 8 equals 0. So we'll subtract 2 on both sides here. We'll have p equals negative 2. And we'll have p equals negative 8. Right? So for number 8, we're going to have negative 2 and negative 8. Okay. Almost done with this section with a is 1. We have 2 more problems with a is 1, and then we'll move on to a is greater than 1. Okay. Number 9. X squared minus 5x plus 4 equals 0. Okay. With these problems, you want to certainly take your time. I'm going fast because I know how to do it. But that doesn't mean that I'm like immune to mistakes. You know, I'm certainly going to make mistakes as we go along, but what's important is just understand the process, right? 4 is 4 and 1, both minus. So we've got a negative 4x and a negative 1x. And I do like to put the negative 1 in front when I have problems like this, so I don't make a silly mistake. Like negative x looks really weird there to me. So putting the negative 1 realizes, oh yeah, well I can't take anything else out, so it's just 1. Or in this case, it's negative 1, right? So if you want to put the negative 1 to make yourself feel a little better, to make it more comfortable, then please do that. As long as you don't leave it a negative 1 or a 1x in your answer, because that doesn't make any sense. That's not mathematical. Okay, factors. I really like this pink marker, I really do. But it doesn't pop, you know? And this is a new pink marker too, it just doesn't pop, so it's okay. Equals 4. Okay, so for number 9, we've got 1 and 4. Okay, one more number in the set, and then we'll move to something else. Number 10. Okay, n squared minus 7n equals 0. So a is certainly 1 here, but we're GCFing. We're not area modeling because it's only 2 terms. N comes out and is by itself, and then we have n minus 7. So we're going to have n equals 0, and n minus 7 equals 0. So n equals 0 takes care of itself. Add 7 to both sides, and then n equals 7. So our values for number 10 are going to be 0 and 7. Okay? I'm going to switch markers, because that's not doing it for me. The pink one, it's not working out. The blue one usually is, kind of pops. So we'll see what that looks like. All right, next set of problems is going to be a is greater than 1 with some GCF thrown in. So if you see a GCF, it's probably going to have an a value that is greater than 1 as well. All right, so let's go ahead. Number 11. Oh, that's way too high. Okay, that's going to be a little bit better. And then I'll erase that when I get along. 2k squared plus 9k plus 9 equals 0. Okay, a is certainly greater than 1 here. And let's work the process out with the area model just like we've done before, right? So we're going to have a 2k squared and a 9. We are multiplying 9, the constant value, times the coefficient of 2, which is going to be 18. I'm looking for factors of 18 that I can add or subtract to 9. And again, we've done one like this before, so it's going to be 6 and 3. And they both have to be plus. So this is going to be 6k, and this is going to be 3k. 2k comes out on top. 3, just k, 3. Now, 2k plus 3 is one of my factors, and k plus 3 is the other factor. When we have a coefficient in one of these factors, it's going to become a 2-step equation rather than just a 1-step, right? So this is 2k plus 3 equals 0. Nothing's changed so far. And then k plus 3 equals 0, but we'll go to that next. I'm subtracting 3 from both sides first, which is going to leave me with 2k equals negative 3. Now, I'm trying to get k by itself, so I have to divide by 2 on both sides. I am going to get a fractional answer here, and that is totally fine. K is going to be negative 3 over 2, and that is an appropriate answer, and that is the right answer, right? If you wanted to get a decimal and divide it, that's fine, but why bother if I'm not graphing it? Because we're not graphing these things yet, right? So I'm just looking for solutions or x-intercepts. There is nothing wrong with this answer, right? So just leave it as is so you don't have to do extra work. Subtract 3 on both sides here, I'm going to get k equals negative 3. So my two values here are k equals negative 3 over 2 and k equals negative 3. When we have an a is greater than 1 value, you will have answers, or at least one answer, that is going to have a fractional result, right? So this is number 11, and our values are negative 3 over 2 and negative 3. So in this set, I'm just going to write them as kind of like an ordered pair, even though they're not. I'm just going to use the comma to represent the differences, or just, you know, a little bit differently than you've seen before. Okay. I wish the board refreshed itself so I didn't have to erase it every time. Number 12. I would bet you that half the video is me erasing stuff. 3m squared minus 8m minus 16 equals 0. Okay. Again, the process never changes when it comes to these things, right? It's just about how you operate within it in terms of speed. Because you certainly do want to get fast at these as fast as you possibly can. 3 times negative 16 is negative 48 for negative 8. 4 and 12. Positive 4, negative 12. Okay, so I need a positive 4m, negative 12m, m, negative 4, 3m, 4. Okay, so we have m minus 4, 3m plus 4, factors, right? Let's set them equal to 0 and solve. Plus 4 gives me m equals 4. minus 4 will give me 3m equals negative 4, and we'll divide by 3 on both sides, which will give me m equals negative 4 over 3, right? So here's my two answers, 4 and negative 4 over 3. All right. So again, solving is like one more step from factoring, and it's a step that makes sense, right? We always want to get the variable completely alone. When in factoring, we didn't really do that. We left it with like the binomial that it was in, or the parentheses that was in. Okay, 2x squared plus 3x minus 14 equals 0. All right. 2x squared, negative 14. 2 times negative 14 is negative 28 for 3. 4 and 7, right? Negative 4 and positive 7, because I'm trying to add to positive 3. So I've got a negative 4x, 7x, right? So this is going to be 2x, 7x. I was going to say negative 4. That would have been wrong. Negative 2. Okay, so just be careful with that kind of stuff. 2x plus 7, well, let's just do the factors first. X minus 2, I'm getting ahead of myself, right? So 2x plus 7 equals 0, and x minus 2 equals 0. Subtract 7 on both sides will give me 2x equals negative 7. And we'll divide by 2 on both sides, which leaves us with x equals negative 7 over 2. Add 2 to both sides, x equals positive 2. Okay, so then we have negative 7 over 2 and 2. Right? I think the blue marker's working out a lot better for us, right? That red one, or pink one. Oof. Oh. Thank you. 3n squared. I heard that, by the way. I don't know how I heard that. It's weird. Is that a 19? Oh, this is going to be a bad one. Okay, here we go. 3n squared, 28. 28 times 3. It's a good thing I have my calculator here. 28 times 3 is 84 for negative 19. Ew. Four times 21 does not work. 6 and 14 does not work. Uh-oh. 2 and 42 does not work. Okay, so 1, 2, 3. Let's try 84 divided by the 3 and the 28 we did, so that doesn't work. 84 and 4 is 21. That doesn't work. Uh-oh. 5 doesn't work because 5 is not divisible. 6 we tried. 7. Does 7 work? It's got to be 7. 7 and 12. Okay. So sometimes you just got to go down the list. I didn't know that. I didn't know this one because I've never divided 84 to get negative 19 in my entire life, ever. All right, so hopefully you won't ever have to do this again after this. Anyway, both minus, right? Negative 7n, negative 12n, n, negative 4, 3n. This is a terrible question. Negative 7. Glad we're doing it together, though. n minus 4 and 3n minus 7 are my factors. Let's go with an n minus 4 equals 0 and a 3n minus 7 equals 0. Add 4 to both sides here. Gives me n equals 4. Plus 7 on both sides here gives me 3n equals 7. And we will divide by 3 on both sides, which will give us n equals 7 over 3. Right? So one of the keys to these problems is to not freak out if you can't find the factors. It'll work, right? So another thing to talk about these types of problems is we're working with factorable quadratics, meaning there is a factor pair that works. It is factorable. It's not going to get you lost. Like, it's not going to give you numbers that don't work. And when I say don't work, I mean that you aren't able to find whole number factors for or integer factors for. Now, I could just make up any quadratic, and it is a quadratic because it'll be a square on the variable, but it doesn't necessarily mean that we can factor it by just, no technology. If you get things like that, well, we're going to find other ways to solve these types of problems, right? 15, 7p squared plus 5p equals 0. So it is both a is greater than 1 and GCF, right? So what is the common factor? And that's just p. And then I'm left with 7p plus 5 equals 0, or as my factors. P equals 0, it took care of itself. And then 7p plus 5 equals 0. We'll subtract 5 on both sides, where 7p is going to equal negative 5, divided by 7 on both sides. P equals negative 5 over 7. We're done there. Okay, 15. 0 and negative 5 over 7. Okay. 5 more in this set, and then we'll go to something different. 16. 5v squared plus 7v minus 24 equals 0. I always am worried about bigger numbers because it takes a little bit longer to find factors of it, unless you're super good with multiplication, which some of us are, right? And some of us aren't. So 5 times negative 24 is negative 120. And I'm trying to find factors of negative 120 that get me 7. Six times 20, but that doesn't get me 7. 8 and 15. Got lucky. Negative 8 and positive 15, because I'm trying to add to 7, right? Negative 8v and 15v. Just v. Careful here, it's 3. Because 3 is divisible by both of those things. This is a 5v, and this is a negative 8. So v plus 3, and 5v minus 8. V plus 3 equals 0, and 5v minus 8 equals 0. Subtract by 3 on both sides gives us v equals negative 3. Add 8 to both sides. This one stinks. 5v equals 8 divided by 5 on both sides. I don't know what that is. And we have a v equals 8 over 5. All right, so we have our two answers. We've got negative 3, and we've got 8 over 5. Okay. Bigger numbers are challenging, right? But we want to go down the list of factors, and then we can go from there. As long as you're careful about the multiplication of it, we're fine. 17. 5n squared minus 4n minus 12 equals 0. 5n squared. Negative 12. 5 times negative 12 is negative 60 for negative 4. 10 and 6. Negative 10 and positive 6. So negative 10n, 6n, 5n on top, 6. n, negative 2. So 5n plus 6 n minus 2, getting ahead. 5n plus 6 equals 0. N minus 2 equals 0. Subtract 6 on both sides gives me 5n equals negative 6. Divide by 5 on both sides gives me n equals negative 6 over 5. Add 2 to both sides and gives me n equals 2. So for number 17, we're looking at a negative 6 over 5 and a 2. Okay, well, a couple more and we're going to jump to the next section. Hope you're doing all right today. 18. Of course you are. You're watching TitanClass. Why wouldn't you be all right? 3b squared. Ooh, is that plus? Ew. It's like Titan slobber on it. 17b plus 24 equals 0. I feel like we've done one like this before. 3b squared, 24. 3 times 24 is 72 for 17. 8 and 9. That one's not bad. Both plus. 8b and 9b. And again, remember, it doesn't matter the order. If you wanted to like manipulate it so it was an easier way to factor one way, that's fine. But you're only going to screw yourself in the end because you can't factor it the way you want to factor it both ways, right? So like I was thinking to myself, I could put the 9b here. So then that's just an easy 3b, but it still works out the same way, obviously. So that doesn't make sense. 3b, 4. Careful, this is a hard one. B plus 3, that was 2 tricky ones, right? And 3b plus 4, factors. B plus 3 equals 0. 3b plus 4, 3b plus 4, haha, equals 0. Subtract 3 on both sides here. Gives me b equals -3. And subtract 4. 3b equals -4. Divide by 3 on both sides. And we have our answers. We've got, for number 18, -3 and -4/3. All right? Okay. 19. That's a 9. 2p squared plus 5p equals 0. Okay, 2 terms. That's a giveaway that we're GCFing. So p comes out, and we're left with 2p plus 5. The p by itself takes care of itself, so it's just 0. And then we have 2p plus 5 equals 0. Subtract 5 on both sides, and we're left with 2p equals -5. Divide by 2. So we're going to have our values of 0 and -5/2. Okay. One more. And it's kind of an ugly one. It's number 20. 35x squared minus 23x minus 4 equals 0. Okay, we don't usually see ones like this. But again, it's factorable or wouldn't have been on the sheet unless Titan is messing with me again. 35x squared for -4. -105 for -23. Ooh, I don't know this one. There's only a couple that it could be. Okay, that was a mistake. It's not -105. I multiplied 35 times 3, but that's a 4. If you caught that, good job. It's -140. What I did originally was I did 35 times 3. 35 times 3 is not what this is. It's 4, right? 35 times 4 is -140. Whew. So 10 and 14 don't work. 7 and 20 don't work. 35 and 4 doesn't work. Oh boy. 6 doesn't fit. 8 doesn't fit. 14 and 10 doesn't fit. It's a hard one. 12 doesn't work. 9 doesn't work. I don't know what this one is. Let's go to y equals, and we'll do -140 divided by x, second table. Let's see what we got. 5 and 28. Calculator to the rescue. +5 and -28. So we're going to have a 5x and a -28x. Wow, I really messed up on this one. I don't really want to edit it though, because this is good. 5x, negative 4, 7x, 1. This is a gross one. Factors are 5x minus 4 and 7x plus 1. Those are the factors, right? So then my answer is going to be, when I set them equal to 0, 5x minus 4 equals 0, and 7x plus 1 equals 0. Plus 4 and plus 4 gives me 5x equals 4. Divide by 5 on both sides, and I'll get x equals 4 over 5. Minus 1 and minus 1 gives me 7x equals negative 1. Divide by 7 on both sides gives me x equals negative 1 over 7. So 2 fractional answers for this one, and no, I promise you I didn't save this one for last because it's a mess. 4 over 5 and negative 1 over 7. So why was it like that? Well, because our coefficient was really, really big. Our a value was really big, and our c value was really small. So that's kind of what helped us get 2 fractional results for our answers, right? All right. So 20 questions down. It took a while, right? Because we're area modeling, we're factoring the whole thing. This next section is going to be on solving by square roots. Not complete the square, and possibly not difference of squares, because difference of squares is a special case. These problems are going to be different because we're just going to use some square roots with some basic knowledge of solving equations in general, right? Not so much even quadratic, but just solving equations in general. So let's take a look. Number 21. Oh, let's see. Good old yellow, right? Number 21 is 36x squared plus 5 equals 9. Okay. This section is going to be the introduction to having imaginary solutions, which we have not had yet because we wouldn't have been able to factor them if they were. So square rooting will allow us to get those imaginary solutions a lot easier than the other sets that we're going to do today. So first step is I want to get everything to the right-hand side. So kind of like complete the square. So minus 5 on both sides gives me 36x squared equals 4. I'm going to square root both sides, and I'm allowed to do that here, right? So then we'll have 6x equals plus or minus 2, right? So it's plus or minus because when I square root a regular whole number, it's the positive and the negative version of that. So when I divide by 6 on both sides, I'm going to get x equals plus or minus. I'm going to simplify this fraction, 1/3. So that is my answer. It's going to be x equals positive 1/3 and x equals negative 1/3. But with the square root process, I can do this cheat, which is like this shortcut, by just putting plus and minus, and it helps me understand that it's both the positive and negative version of that number, right? So my answer for this is going to be plus and minus 1/3, which really just means positive 1/3 and negative 1/3. So I'll just do plus and minus 1/3, so we know that that would be the answer for that problem. Okay? This section will probably go faster than the other two because I won't have a ton of area model stuff to do. All right, so 22 is, we're going to get an imaginary solution here. So we're going to have 8x squared plus 7 equals negative 100. Now that should be the giveaway, that that's already a negative and it's a big number. Even if I subtracted the 7 on both sides, or if I added it for that case, I'd have 8x squared is going to equal negative 107. Now, one other thing that we can do here is this. There is no perfect square for 8. 8 is not a perfect square. So let's divide by the 8 on both sides, because what is going to allow us to do is get the x by itself. So we're going to have x squared equals, now these two numbers don't fit into each other nicely. They don't divide evenly. So I can leave it as an improper fraction. We'll square up both sides. Now this is where it gets a little messy. X is going to equal plus or minus the square root of negative 107 over 8. But we're not allowed to leave it like that. And the reason is because when I square root the entire fraction, it is going to be plus or minus the square root of negative 107 over the square root of 8. And that is what that means. But remember about rationalizing denominators, I can't leave the denominator like that. So first thing we need to do is there's a negative under that radical. We're going to take that negative out because that negative is just I. So let's go up here. Plus or minus I root 107 over root 8. So we're going to rationalize that denominator. I don't know why I did that. Square root of 8 and square root of 8. Okay, so this is going to end up to be plus or minus I root This is ugly. Okay. 107 times 856. This is simplifiable, it's to some degree, over 8, right? So this is going to simplify to, or it's going to end up to be I root 214 over 4. So what will happen is this. I can simplify the square root of 856 into two different things. Now, I'm going to save you that trouble because when I simplify 856, it's going to allow me to get rid of the 8. Now, 856 simplifies to 4 times 214, but 214 doesn't have a radical that it's a perfect square. So that's why the 214 sticks around. And the 4 would come out, but I can simplify that fraction further. So it is where I get my I, plus or minus I root 214 over 4. Okay, number 23. 23 is 7a squared plus 9 equals 576. Okay, again, we're working with the square root method. Not solved by factoring because we're on square roots now. No one told me to change that. Minus 9 on both sides. 7a squared is going to equal, ooh, wow, what? 567? Oof. Let's divide by 7 on both sides first, because 7 is not a perfect square, so square rooting, that's going to be a mess. A squared is going to be a calculator. A squared is going to be a calculator. Wow, that divides really nicely. Okay, so that's a perfect square, so we're in good shape here. Square root both sides, and I'm going to have a equals plus or minus 9. Awesome. Love when questions end up like that. Okay, so both the positive and the negative version of 9 is my answer. Let's go to number 24. You okay, buddy? Breathing really heavy over there. Okay, number 24 is 3x squared minus 8 is going to equal 208. We're going to add 8 to both sides. 3x squared equals 216. Okay, now again, unless there's a perfect square number coefficient in front of the x squared, I really, really want to get rid of that number, right? Otherwise, I could square root both sides, but let's just make it easier. So we're going to have x squared is going to equal, this should be something that's pretty easy, 72. Okay, now we're going to square root both sides. 72 is not a perfect square. 72 can get broken down. So this is x equals plus or minus the square root of 72. Off to the side, let's break this down. So the square root of 72, I'm looking for a perfect square factor. A lot of you are going to tell me 8 and 9. And 8 and 9 is fine because 9 is a perfect square. But 8 can get broken down again. So if you were to do 8 and 9, you will get the answer eventually. But the biggest perfect square here is actually 36 times 2, right? And we'll practice that in another video with breaking down these radicals. The square root of 36 is just 6. Times the square root of 2 is 6 root 2. So my answer here is x is going to equal plus or minus 6 root 2. Okay? So be really, really careful. The tricky part is you might run into some radicals that need to be simplified. So plus or minus 6 root 2. And we're on the back page, even though we still have 25 problems to do. This video is taking a little longer than I had imagined. But you know what? It's all good. We're here. We're making it work. Number 25. 3x squared minus 3 equals 48. Okay, we're going to add 3 to both sides. 3x squared is going to equal 51. We'll divide by 3 on both sides, which is going to give me x squared equals, I should know this in my head, 17. I didn't. We're going to square root both sides. Now, the square root of 17 does not have a perfect square factor, and it's not factorable in any other way. So my answer is actually going to be x is going to equal plus or minus the square root of 17. All right. Now remember, when I talk about exact values, like I want exact values or your teacher wants exact values, this is an exact value, right? Because if I were to get a decimal, it's going to be a messy decimal. This is an irrational number, which means its decimal will go on with, it will repeat with no pattern, right? So it'll be all kinds of weird, crazy stuff going on. So this is an exact value. That's what we call exact. It's exact. It's exact. It's exact. Yeah. 26. This one might be a little messy. 4n squared plus 4 is going to equal 29. We're going to subtract 4 on both sides. Okay. 4n squared is going to equal 25. All right, interesting. Now, we can do a couple different things here. Because 4 is a perfect square, I can actually square root both sides. So let's do that and see what happens. If I were to square root both sides here, I will have 2n is going to equal plus or minus 5. Now I can divide by 2 on both sides, and this is going to be n equals plus or minus 5 over 2. That's actually the answer, and I'm good with that. I'll sidebar in a second after I put my answer here to show you what it would look like otherwise if you did something different. So let's say we were at this level, but we didn't want to square root. Let's just say we wanted to divide by 4 on both sides of this equal sign. So if we divide by 4 and we divide by 4, we'll have n squared is going to equal 25 over 4, which is still fine. This way looks a little uglier because they don't divide evenly. Square rooting both sides is kind of like a problem we did a little bit ago. This means I'm square rooting the top number and the bottom number individually. Well, this is okay because the square root of 25 is just 5 and the square root of 4 is just 2. But remember, when we square root, it's going to be plus or minus that value. So this way worked out either way. I'm a little bit more fond of just square rooting both sides than doing all this because this is a weird rule that not a lot of people remember. So I'm okay with this. Now again, this only works well, or it only works when your coefficient number is a perfect square. Like if that was a 6, that would not work very well, right? So just be careful about what you see, but know that there are multiple different ways to do this and still come to the correct answer, right? All right, 27. That's an ugly 7, by the way. 64n squared minus 4 equals 12. We haven't had an imaginary in a while. We'll have to wait a little bit more for that. Add 4 to both sides. I don't know, my head's in the way. 64 n squared equals 16. Okay, now, 2 perfect squares again. I'm able to square up both sides because I've got 2 perfect squares, or I got 1 perfect square here. This is 8n equals plus or minus 4. Okay, so we'll divide by 8 on both sides. Now we gotta be careful because we have to simplify. N is gonna be plus or minus 4 over 8, but 4 over 8 simplifies to 1/2. So my answer for number 27, or my answers, is plus or minus 1/2, right? So we always have to simplify the fraction if it calls for it, which it did, obviously. Okay, 28. 4k squared plus 5 equals 21. Okay, so subtract 5 on both sides, right? These are multi-step equations, and it's totally fine because you've been doing this since Algebra 1 and before. 21 minus 5 is, 16. All right, well, it looked but it's not. 2 perfect squares again. Let's square root both sides. 2k is going to equal plus or minus 4. Divide by 2 on both sides. K is going to equal, remember we're simplifying this, plus or minus 2. All right, so that's my answer for this value, plus or minus the value of 2. All right? And again, you can plug it back in if you really wanted to. I wouldn't, but if you weren't sure and like, I'm not really sure my answer, you could plug these values back into K and then evaluate this stuff. And if you were to get, 21 equals 21, then you know you're right. You're always allowed to do that with equations. Like the checking process is actually pretty fluid. You just need to make sure you put it into the right location, right? 29. Okay, we're gonna have an imaginary solution here. 6x squared minus 1 equals negative 14. Okay, and we know it's gonna be imaginary because the value by itself on the right-hand side is negative. So let's add 1 to both sides. 6x squared is gonna equal negative 13. I am gonna divide by 6 on both sides here, right? Because that's gonna make my life a little bit easier because that's not a perfect square. All right, so x squared is gonna equal negative 13 over 6. All right, take one step at a time. First, we're gonna square root both sides. This is gonna be x equals, let's just throw the plus or minus in there first. Negative, the square root of negative 13 over the square root of 6. That's not a negative, I apologize. Okay. The negative sign under the radical is going to come out and it's going to be I. So let's go ahead and reevaluate this. X equals plus or minus I root 13 over root 6. I have to rationalize the denominator though, because I'm not allowed to have a radical in the denominator. So this is going to be x equals plus or minus I Root 13 and root 6 together is 78. Ew. Over 6. Now, the square root of 78 is certainly not I can take a 2 out, obviously, but 2 is not a perfect square. I cannot actually simplify this, so this number is irrational in terms of the decimal value. So I can't break this down any further. 4 doesn't fit in, 9 doesn't fit in, 16 doesn't fit in, 25 obviously, 36, things like that. So we have a problem. This is actually the answer. So this is going to be, and we want to keep the I in the numerator. It's x equals plus or minus I root 78 all over 6. And that is my answer for this problem. So be really careful. We had a multitude of things happening, right? So we had some non-perfect squares with an imaginary solution. We had to square root a nasty fraction. Remember that it's the broken down part, so it's going to be the numerator and denominator of a radical. And then we had to rationalize. This problem is not fun, right? So I root 78 over 6 is my final answer here. Really, really nasty problem. You got to be really careful here, okay? We'll probably run into a couple more like that as we go along, but that's just something to be careful of. All right. Number 30, and then we'll have 5 more problems in this set, and then we'll go to complete the square. 30 is 10n squared. I think that's a minus 7, equals 463. Okay? We will add 7 to both sides of the equation, which is going to give me a 10n squared equals 470. We can divide by 10. This is actually going to be pretty nice. N squared is going to equal 47. 47 is not perfect, but we don't have a lot of mess like we had in the last problem. N is going to equal plus or minus the square root of 47 because I don't have a perfect square factor of 47. Right? So our last problem in this set of 10 is plus or minus the square root of 47. All right, 5 more problems, and like I said, we'll jump to complete the square. I think these are going to be pretty simple comparative to the other ones. 31. 2m squared plus 2 equals 176. All right, we're going to subtract 2 on both sides first. I'm left with 2m squared equals 174. We're going to divide by 2 on both sides to make this 174 a lot smaller. And again, 2 is not perfect. It's not a perfect square, so I don't want to do that. This is, 87? We'll square both sides. Sometimes, like when these numbers are like I can't, my brain doesn't work. M is going to equal plus or minus the square root of 87. 87 is not a perfect square, nor does it have a perfect square factor. I can't factor that any further. So number 31 in this new set is going to be plus or minus the square root of 87. All right. All right, moving along. Okay. I mean, with equations, you just gotta, I'm going fast, obviously, but you want to slow down to make sure you don't make a silly mistake. These are things you've been doing for years. It's just a different package, right? It's just a different wrapping of the package that you've done forever, solving equations. 32. 36k squared. That was a piece of dust. That was weird. Plus 2 equals 66. Okay. I don't know why 2 happens so often. That's so weird. 36k squared equals 64. 2 perfect squares. All right, this is good. So let's break this down. And you might be saying to yourself, how do you know that they're perfect squares? Well, I mean, we have to know our perfect squares. And we really want to know our perfect squares up to, you really should know them up to 25. Like 25 times 25 is 625. So you should know that 625 is a perfect square. But I'll break that down some. You should know your perfect squares up to 10 or 12, right? So 10 times 10 is 100, 12 times 12 is 144. You should know up to that level, right? So it might be a little bit easier as we go along. Okay, so now I'm going to divide by 6 on both sides. K is going to equal plus or minus. It's not 8 over 6 because 8 over 6 can get simplified. So our answer is going to be plus or minus 4 over 3. All right, so 32 is plus or minus 4/3. Okay. Always simplify. And again, perfect squares are really, really important when we talk about solving quadratics, because we're square rooting all the time in theory. 33. Oh, this one's really bad. -8, what? Minus 8n squared. Ugh. Equals -600. Oh my goodness. Okay, wow. That's a 600. Okay. Wow. Okay. There's a couple things we can do here. I could certainly move this 600 over here to keep things together. The problem with doing that, unfortunately, is this. I have a negative in front of that square. Like this squared term has a negative in front of it. I do not want that. I really don't want that. So here's what I'm going to do, and this is going to be very strange. I want to avoid a negative in front of the squared term at all costs. I'm actually going to move everything around. Hear me out. I'm going to add, well, not everything. I'll keep the negative 8 where it is. I'm going to add 600 to both sides first, which is going to give me a negative 8 minus 8n squared plus 600 equals 0, right? Because I moved it. All right, now let's move this 8n squared over to the right, because I don't want that there. I don't want that there. I don't want the negative there. All right, so now we have a negative 8 plus 600 is going to equal 8n squared. Now, we can combine the negative 8 and the 600, obviously, right? So that's going to be 592 equals 8n squared. And we could have combined it the first time, but I wanted to show these steps. Now I can divide by 8 on both sides. I know this looks weird because the squared term's on the right. It doesn't matter. It's the same thing. It's just very funky looking. So let's divide these two things. So 592 divided by 8 is 74. So we're going to end up with something that's actually not bad. Now, 74, it's not a perfect square, nor does it have a perfect square factor. It is divisible by 2, but if I divide it by 2, it's just 2 and 37. And 37 is not perfect either. So we're going to leave it like this. This is going to be n equals, and I'm going to keep the same pattern of this so it doesn't get messed up, plus or minus the square root of 74. I realize it's like a mirror image or reflected, so it's just weird, right? But it's still the same process of an equation. So we're going to have plus or minus the square root of 74 on this problem, okay? 2 more and we'll jump into complete the square, which is the grand finale of our problems for today. All right, so 34. This one's not bad because we have a 64, which is a perfect square. 64x squared plus 2 is going to equal 102. This is very simple because I can see already this is going to be 100. Minus 2 on both sides. I'm going to have 64x squared equals 100, right? That's an equal sign. It's like the marker's drying out. I've wrote so much for this video. Square root both sides, and I'm going to get 8x equals plus or minus 10. We'll divide by 8 on both sides, which is going to give me x equals plus or minus. And remember, we've got to simplify. This is going to be 5 over 4. So my answer for 34 is going to be plus or minus 5/4, or 5 over 4. Okay. And again, last one in the set. And it's not terribly bad. 35 is going to be 49n squared minus 8 equals negative 7. We'll add 8 to both sides, which will get rid of that negative, right? 49n squared is going to equal 1. 1 is a perfect square because 1 times 1 is 1. So we can just square both sides. 7n is going to equal plus or minus 1, right? Because negative 1 times negative 1 is also 1. We'll divide by 7 on both sides, and our final answer is n equals plus or minus 1 over 7. Whew-wee. We're getting there. All right, next and final part of our Titan class video today is going to be completing the square. Completing the square is a process, right? And as long as you understand the process and why we do the process, we're good to go. Let's jump right into it. 36. Okay. N squared plus 2n minus 1 equals negative 4. We are going to have an imaginary solution here. First step is to move the c term to both sides. N squared plus 2n, and we put an empty box where we moved it because we want to fill that box or we want to complete the square. So this is going to be a negative 3, and we're going to complete the square by putting a box there too. Take the middle term, divide it by 2, which is 1, and square the result, which is 1. That is the number that completes the square. Right? So the process of dividing by 2 and squaring it completes the square for us, but on our next line, it proves why we need to do that. Because on the left-hand side, plus 1, right, I filled the box, equals negative 1 plus 1, I'm sorry, negative 3 plus 1, which is negative 2. Because on the left-hand side, we're left with what's called a perfect square trinomial, which is necessary in order to complete the square, at least solve by completing the square because it helps us factor easier. We're now going to factor this part, and the number that we had before we squared it is that part. So n plus 1 squared is going to equal negative 2. Now we square root both sides, and herein lies the problem where we're going to have our imaginary solution. This is n plus 1 is going to equal plus or minus. Remember, the negative comes out, it's just I root 2, okay? So when you see the negative under the radical, just make it an I, because we know it's negative 1. And the 2 obviously can't get broken down, so we just put the square root of 2 there. Now we have to complete this cycle by adding 1 to both sides. Our answer is going to be n equals negative 1 plus or minus I root 2. This is really, really important, right? That negative 1 can't combine with the root 2, obviously. You could have certainly put it behind here, but that's messy. Put whatever you move in front of the plus minus, because the plus minus only applies to the I root 2, because this is positive I root 2 and negative I root 2. Okay, there are two differences there. So our answer for 36 is going to be negative 1. I literally just made the mistake I told you not to make. Negative 1 plus or minus I square root 2. Okay. Now, complete the square is a lot of work. We just did a ton of work for that one problem alone. However, it is going to be extremely helpful for us to get our solutions to any kind of quadratic, okay? Now, we're only going to see a certain type of these problems in terms of their even. You might not have a coefficient in front. You can certainly do that, and it just makes it a little bit more complex. But for purposes of this review, this video, it's going to be more of A is 1, and our B term, or our middle term, will be even, okay? 37, n squared minus 14n minus 48 equals 3. Okay, completing the square. Right, so we're going to add 48 to both sides. It's going to leave me with n squared minus 14n square equals 51 square. Take the b term, divide it by 2, which is negative 7. Square the result. Now, if you put this in the calculator, please don't, but if you need to, know that your result will always be positive. It is not possible to square a number and get a negative result. That's not how that works. So if you put this in the calculator without parentheses, it's going to say negative 49. That's not right. The calculator is doing what it asks you to do. Just know that it's positive. It always will be, right? That will never change. So it's positive 49 that goes in the squares. We have now completed the square. N squared minus 14n plus 49 is going to equal 51 plus 49, or 100. Now, for those of you who got the eagle eye, we're going to have two integer solutions here because there's a perfect square on this side. Right? So let's continue our process with factoring. This is n minus 7 squared equals 100. This is going to be a nice one. Square root both sides. N minus 7 is going to equal plus or minus 10. Now, I can combine these two constant terms of these two integers. So we're going to do that, but we have to do it twice, right? So when I add 7 to both sides the first time, positive 10 plus 7 is 17. So n equals 17. Now, we have to do this again when it's the minus sign. Negative 10 plus 7 is negative 3. You have to do this twice. When you can combine them, you have to do this twice, right? So all the square roots we did before, they're all plus or minus. Well, that makes it easier because it's just plus or minus. We really couldn't add or subtract anything. But when we complete the square, we're going to have values sometimes that we can combine, meaning like terms. In this instance, they're like terms. So I have to do the positive and the negative version of that 10 to get two answers. You can't just slap plus or minus on it and say, oh, it's going to be plus or minus 17. It's totally dead wrong, or you're half wrong, right? So you've got to evaluate it when it's a positive value and a negative. Now, one last thing and we'll move on to the other problem. I'm still adding 7 both sides, no matter what. Like, I'm not subtracting 7. That's a minus 7. I'm not subtracting it. That doesn't make sense. We will always do whatever the opposite of this is to move it. The value that was square rooted, however, that's going to be the thing that changes, right? So be really, really super careful with how you end these problems. 17 and negative 3. It would suck if you did all this work and you got your values, but you just put the wrong or you got the wrong evaluation at the end of it. That would be terrible, right? So just be really careful. 38, x squared plus 14x plus 84 equals 4. This one's going to be ugly. Minus 84 on both sides, and I know it's going to be ugly because look, we have such a big negative already. X squared plus 14x squared equals negative 80 square. Remember, always combine the terms when you move them over so we don't have to take another level. 14 divided by 2 is 7. Squared is 49. That was like the last problem. That's the number that completes the square. X squared plus 14x plus 49 is going to equal, it's still a negative, and it's negative 31, right? Because that number that was the square isn't big enough to overcome this negative that's there, right? Factor, this is x plus 7 squared. That's a 7. Ew. Equals negative 31. Let's square both sides. X plus 7 is going to equal plus or minus. Remember, when it's a negative, I comes out, root 31. Now, I can't break down 31, so my answer is actually going to have a 31 under the radical. We are still subtracting 7 on both sides. Final answer is going to be this. X equals negative 7, because that comes first. Then we can do the plus or minus I root 38. This is my final answer. Okay? And again, not like the last problem. I can't combine negative 7 and a square root with an I. So it's actually, I mean, it might be a little easier to not make a mistake because I can just slap the plus or minus on it and be done. 38 is going to be negative 7 plus or minus I root 31. Okay? So I don't know, you might think like, oh, imaginary number solutions are harder. Yes and no. I mean, that might require another second of thought, but it's problems like 37 where you can make a really, really, really simple mistake if you're not paying attention. And hopefully you won't be sitting down doing 50 problems like I am. This is like going to be a 2-hour video. Probably at least. 39 p squared minus 4p plus 35 equals negative 7. Okay, subtract 35 on both sides. P squared minus 4p square equals negative 42 squared. Take the negative 4, divide it by 2, which is negative 2. Square the result, which is 4. Remember, it's always going to be a positive. Throw the 4 into the boxes. We have completed the square. B squared minus 4p plus 4 is going to equal negative 38. Okay, so yuck. We'll factor the left-hand side, so p minus 2 equals negative 38. Square rooting both sides is going to give me p minus 2 equals, remember it's I root 38, and it's just 38 still because I cannot take a perfect square factor out of 38. It is divisible by 2, but 19, its other factor with 2, they're not perfect, and I can't go any further because 4 doesn't fit. So we're going to add 2, and we will complete this problem. This is going to be, plus or minus. Answer is going to be p equals 2 plus or minus I root 38. Okay? 2 plus or minus I root 38. It's so funny. If you pay attention to the videos, every once in a while, like I will actually just stop moving, and you'll think that like you paused it, but I'm actually like I just literally stopped thinking for a second. It's very strange. It's very strange. It's 40. Last number in this set of 10. Okay, we've got x squared plus 6x plus 59 equals negative 7. All right, negative 59 or minus 59 on both sides gives me x squared plus 6x square equals negative 66. Ew. Square. Take the 6, divide it by 2. 3 squared equals 9. That is the number that completes the square. So we're going to have x squared plus 6x plus 9 equals negative 57. Ew. These numbers have been really ugly the last couple ones. This is x plus 3 squared equals negative 57. We'll square up both sides. And I'll be left with x plus 3 equals plus or minus I root 57. Because again, 57, it is divisible by 3, but the other factor is not perfect. And we'll subtract 3 on both sides. And then we'll have x equals negative 3 plus or minus I root 57. Okay, so that's our final answer for the last one here in this set. Now, I get a lot of questions about skipping steps. I'm always really against skipping steps when we're doing problems out, because if you understand the process, and the process is kind of how like you get your answer, or how you ensure that your answer is correct, I wouldn't skip any steps ever. Now, if I was doing 50 problems for homework, which God forbid you are, that's awful, right? It's terrible. It's like torture, right? You probably want to skip some steps. Now, if you were doing a problem like this, and you're like, yeah, I want to skip this step right here, right? This step. That's fine. Like, just make sure if you skip steps, you still 100% of the time, or darn near 100% of the time, get the right answer. right? Skipping steps in math is never a good idea, ever. But if you can do a lot of these things or some of these things in your head and you're like, man, I really just want to skip this step, dude, do it, right? Just be sure that you still get your answer 100% of the time, or again, really close to it. 41, 10 problems left. We're in the home stretch. 41, n squared minus 14n plus 46, brain stopped right there, did you see it? 6 minus 46 on both sides. I'm left with n squared minus 14n square equals negative 40 with a square. Take the 14, negative 14 divided by 2, negative 7. This is another 49. What? Oh, yay, we won't have an imaginary. Oh, this is going to be a nice one. Okay. 49 is the number that completes the square, so we're going to have n squared minus 14n plus 49 equals 9. Whenever it equals 9 on this last step, it's perfect. It's a perfect square, so we know we're going to be looking good. This is n minus 7 squared equals 9. Square of both sides is going to be n minus 7 equals plus or minus 3. Now, just like that other one, which was on the last set, right? Yeah. I'm going to have to evaluate this for the positive 3 and then the negative 3. So we're going to add 7 no matter what. Let's do the positives first because positive is on top here. Positive 3 plus 7 is 10. Let's get rid of that. If you want to erase that on your paper too, that actually is a good idea because now you're like, oh, I know I have to do the negative now. Negative 3 plus 7 is 4. So my two answers are 10 and 4 for number 41. And 4. Okay. All right. 42. And as always, you can pause me, work out these problems. I write the answers down, so if you want to just kind of get the questions and then write them down and then try them yourself, check your work, then you're looking good, right? Whatever you need to do to make sure you get these things right, right? Just make it work for yourself. X squared minus 4x minus 72 equals 3. Okay, we will add 72 to both sides. My glasses are in the way. X squared minus 4x squared equals 75 square. Take the negative 4, divide it by 2, negative 2, square the result, which is positive 4. That's the number that completes the square. X squared minus 4x plus 4 is going to equal 79. Okay, that's not a really great number, but it's not factorable either with the perfect square. X minus 2 squared equals 79. Square of both sides. X minus 2 is going to equal plus or minus the square root of 79. Again, 79 doesn't have a perfect square factor, or the square root of it does. So we're going to leave it as such. We're going to add 2 to both sides. Answer is going to be x equals 2 plus or minus the square root of 79. And on answer keys, you might see it a little bit different. You might actually see it written out. Like it might say 2 plus root 79, comma, like another part, 2 minus root 79, and that's fine, it's the same thing. This is just a little bit more efficient.